Hello and welcome to another video in the lecture series entitled Advanced Biomaterials. My name is Tamojit Santra and I am a second year PhD student in the Department of Biological Sciences and Bioengineering, IIT Kanpur. So in today's video we will be looking at a very interesting aspect of material science, or very interesting component of material science, which is known as polymers. So we might have heard the term polymers in several day-to-day activities. The most common examples of polymers which we come across are the plastics, and also the rubbers are some among them. So what are polymers? Polymer is defined as a natural or a synthetic class of materials consisting of very large molecules or macromolecules composed of many repeating subunits. So the very essence of polymer is it is a multiple subunit or a repeating subunit of a single individual component known as a monomer. So several groups of monomers join to give rise to a polymer. So essentially a polymer is a combination or an arrangement or a complex consisting of different monomeric units which are joined to give polymer. So the term polymer implies the repeating unit. Or the repeating subunit. So a monomer is an entity which has only a unique chemical structure which can join to form which can join in several ways or join in several arrangements to give rise to polymers. So if we assume a monomer as a single unit, if two monomers come together, it will give rise to what it is known as a dimer. So two monomers will give a dimer. Similarly, if three monomers come together, it gives a trimer. And if less than about or less than equal to 10 monomers come together, it gives rise to an oligomer. And if several of these monomeric entities combine through some specific bonds or with some linkages or attachments, they give rise to what is known as a polymer. So let me erase this part. No matter. So then these polymers can be of two types. So polymers can be natural polymers and the synthetic polymers. So let me write it here. So the natural polymers include the proteins and the polysaccharides. So we might have heard about the term proteins in several of our day-to-day activities. So these proteins are polymers of individual components known as the amino acids. So when several of these amino acids join, they give rise to proteins. So an amino acid essentially has an amine group and a carboxylic acid group. So if we assume that this is a basic structure of an amino acid, So if there is an NH2 group here of another carboxylic acid, so this will lead to what is known as the elimination of a water molecule to give rise to a C double bond O and H linkage, which is known as an amide linkage. Amide linkage or an amide bond. So this is how two individual amino acids can join to give a dimeric molecule, and in this way, if several of these molecules can combine or can join, it will give rise to what it is known as a protein molecule, right? So let me erase this part. So apart from proteins also, there can be this another group of natural polymers which are known as these the polysaccharides. Such as the starch and cellulose. So these are made up of the individual sugar molecules. So these can be joined using a glycosidic linkages to give rise to these polymeric entities. So this was the example of the natural polymers. Now coming to the most important groups or the most important types of polymers in different industrial applications or in synthetic applications, these are mainly the synthetic polymers. So synthetic polymers are the polymers which are made from monomeric entities or chemical compounds which do not exist naturally. These are chemically synthesized, and after chemically synthesizing them, they are linked or they are joined to each other in a long network to give rise to what is known as a polymer. So one example of a synthetic polymer can be ethylene. The monomeric entity will be ethylene, and after combining them, it will give rise to what it is known as a polyethylene. So ethylene is one of the most basic types of monomers which are used in preparing these polymers. So this is ethylene. And after polymerization, it will give rise to polyethylene. So one interesting thing to note here is that the monomers and the polymers are structurally very different from each other. That is, once after polymerization takes place, the polymer has properties and structure and properties which are fundamentally very different from the individual monomeric entities. So this polymer, and also after polymerization, it has multiple applications. So the applications of ethylene is that it is used in the manufacturing of plastic bottles, and bags, containers, and packaging films. Now, one more interesting thing to note here is the subscript N. So what is N? So N essentially means the degree of polymerization that is the number of units which are linked together. So N represents the degree of polymerization or the number of units that are linked together. So N is the single repeating unit in case of ethylene. So after adding different structural unit in both the sides, we will get a chain of this, essentially this repeating unit. So this will give our polyethylene PE, which is one of the most industrially significant or applicable polymers which are used in different wide range of applications in the industry. So coming to another example of a synthetic polymer, is polyvinyl chloride or PVC, one of the most used plastic types of materials which we use frequently in our day-to-day applications. So the monomer for this polyvinyl chloride is the vinyl chloride group or the vinyl chloride moiety. So this vinyl chloride is represented as C double bond C, one chlorine group and the remaining hydrogen. So this is vinyl chloride. And after polymerization, it gives rise to polyvinyl chloride. So this polyvinyl chloride is, or PVC, is a white brittle solid. It's a plastic material. So this is used for making polyvinyl chloride bottles, pipes, plumbing equipments, packaging bodies of different structures which are made from plastics, instruments, equipments, and so many other applications of this polyvinyl chloride. But this monomer, the vinyl chloride, is an inflammable, toxic, and a colorless gas. So after polymerization, we can see a profound change in its physical or chemical properties of the original parent monomer, which is used for making the polymer. So the structural and functional properties of the monomers are very different from that of the polymers. Now coming to the classification of polymers, so there are different classes of polymers, or the different ways in which these polymers can be classified. So based on the properties, there can be different types of classification of the polymers. We can look at some of them. So coming to the classification of the polymers, in one particular manner of classification, they can be classified as thermoplastics, thermosets or the thermosetting plastics, elastomers and the synthetic fibers. So thermoplastics are the ones that the plastic materials which once formed or once molded into the given shape can be heated, they can lose their shape, they can be again converted into a fluidic or a soft rubbery state, and then can be again molded into a different shape. And this cycle can in fact continue for a certain number of repetitions or a certain amount of cycles. So heating, cooling, reshaping, molding, so this process can continue. So plastics which can be heated, they can be converted from their hard state into a soft state, they can be molded again, and again they can be heated, converted to another state, and liquid or a semi-solid state, and can be molded again. So these are known as thermoplastics. Now thermosetting plastics or the thermosets are the ones which once after being molded into a particular shape and cooled, they cannot be heated and again converted to their rubbery or soft state. So once they are cast, once they are made into a given shape, they cannot be changed, they cannot be converted to any other form or any other shape once they are set into a particular mold. Elastomers are another type of polymers which have this elastic property that they can be, they show this elasticity and other specific types of mechanical functional properties. And again there is the synthetic fibers, which are like fibers and can be spun and can be fabricated into different shapes. So this was one of the classification of the polymers based on their properties, based on their final appearance or final fabrication, based on their fabrication methods, their mechanical properties. Now there can be another classification of polymers based on their based on the chemistry or based on the structure of their individual monomeric units. So these can be, the classification in such case would be the another form of classification, which would be homopolymers and copolymers. So as the name suggests, polymers made up of multiple species or multiple copies of a single repeating unit is known as a homopolymer. So a homopolymer will have multiple copies of a single repeating unit. So both the examples, vinyl chloride and ethylene, polyethylene, which we have seen in this video, both are the examples of a homopolymer. And a copolymer would be a polymer which is formed when two or more different types of monomers are linked together in the same polymeric chain. So two different types of entities or two different types of monomeric groups altogether, or two different species of monomers, which when linked in the same polymeric chain will give rise to what is known as a copolymer. An example of a copolymer is polyethylene vinyl acetate. So an example would be polyethylene vinyl acetate. So homopolymer would mean a single repeating unit or a single repeating unit which will be present in multiple copies, and a copolymer would imply two different types of repeating units which will be in a same polymeric chain. So with this we finish the basics of what are polymers. So we have seen, on a brief recap, we have seen what are polymers, what are the examples or the classification of polymers based on what, if they are natural or the synthetics. We have seen how the polymers are formed through polymerization reactions. So there can be different types of polymerization reactions which can give rise to these polymerizations. So also based on this based on the other classifications, we have seen that these polymers can be thermoplastics, thermostats, elastomers, or synthetic fibers. We have also seen based on the type of the repeating unit, they can be classified as either homopolymers or copolymers. Also, we have seen the applications of some of the main groups of polymers, that is natural polymers and synthetic polymers. So with this, we will end today's lecture video. Hope you enjoyed it and see you in the next video. Till then, thank you.